Assalamualaikum and good evening to our lecturer, Madam Zaharia. So today we would like to present about the assignment Discrete Signal and System. This is my group members, Siti Masyara, Nur Nadia and Dada Naufal. So my name is Muhammad Fahman bin Muhammad Syafatil from BET 1/2. So my part is introduction. So the discrete Fourier transform or as known as DFT is a type of Fourier analysis that convert one function into another. In other words, it is usually in the temporal or spatial domain and frequency domain. DFT is commonly used in a signal processing and relate discipline to evaluate frequencies in a signal, solve partial differential equation, and conduct other operations like convolution. Fast Fourier transform is an efficient version of DFT that is used in digital image processing, among other things. It is computationally faster to apply feature in the frequency domain than in the image domain. So in this assignment, we had do 3 different tasks. For task 1, I will pass to Siti Maisara.
My name is Siti Maisara. I will present for task 1. This is the coding for task 1. As you can see, for the first line is the link for the image that we put, and then first image is input image. Okay, for this task has 6 image: input image, gray image, Fourier transform image, center Fourier transform, log transform, and reconstruct image. This is formula for figure 4, and then this is formula for figure 5. This log formula, and then this is the coding for figure 6. So I run for this coding and get the 6th figure. Okay, next slide we can see the figure for next slide. Okay, this is for figure 1, the input image. So the real image lah, the real image that we put for this task. And then this is second image, that is gray image. And then this is the third image, that is Fourier transform of an image, just dark. And then the fourth image is center Fourier transform of image. As we can see, for this image has white dot. This is the same for as image 3, but for image 4 has a white dot at the center. And then this is the figure 5 is log transform image. And then for figure 6, reconstruct image just like figure 2. Okay, just that for task 1. Next presenter.
My name is Nuradia binti Azahar. I present task 2. For task 2, I have to apply a blur effect on original image using Gaussian kernel, and I have to observe the change in the output image with different standard division value. So for the first line, I use command I equal imread and I put picture image link in the coding. So for third line, I put I blur 1, I blur 2, I blur 3, I blur 4. So I blur 1, 2, 3, 4. The function is the value of standard deviation. So I is a original picture and 2 is standard deviation value. And then for line 8 is original image. For line 12 is division standard deviation value for 2. And then I put next figure 2, figure 3, figure 4. I put 4 figure because I want to see the difference between the picture. So the next, the result. Next. So this is the result for task 2. So this is for original image. This is for sigma 2, sigma 4, sigma 6, sigma 8. So the conclusion here is when the sigma or the standard deviation value increase, the picture become blur. So here is the result. That's all for me for task 2. So next present.
Okay, so task 3. I will use the image to apply the filter of Laplacian of Gaussian. So on the first line, it shows the location of the image that I will be using. So at the line 6, I'm using the code F special to use the filter, and I set 4 standard deviation: 0.1, 0.2, and 0.2, 0.4, and 0.5. So I'm using the coding IM filter to apply the filter to the image, as you can see at line 7. So when you apply this filter, it will increase the accuracy of the image. Next slide. So as you can see, the left side of the picture is the original image that I used. The second one is the bottom. There is black and white, but the accuracy of the image increase. And so on at the second image. The picture is getting darker, but the accuracy has been increased and the line become more clearer. So what I can conclude from this task 3 is that when the standard deviation is increased, the accuracy of the image gets better. Next presenter. So in conclusion, after do the task that have been given, student will be able to see original image of group members in the frequency domain using fast Fourier transform and rebuild the picture to its actual domain based on this project. As we can see from the task 1, the picture become black and white, then it become dark after we apply in the coding using MATLAB. So next, student be able to know about how to apply a blur effect on original image using Gaussian kernel. As Nurul Nadia present for part 2, the picture become blur until we can see the original image. So for conclusion number 3, student will be able to determine the age of the original picture. At the task 3, we can see the picture. At original, we can see many colors, and after apply in the coding, it become darker. So that's all from us. Thank you, madam.